Hi guys, so today we'll be solving minimum number of refueling stops. A car travels from a starting position, a 0 index, to a destination which is target. There are gas stations along the way. It is represented by position field. Indicate that a gas station is at position I and has few liters of gas. So the car starts with an infinite tank of gas which initially has start fuel in it. It uses 1 liter of gas per 1 mile that it drives. So when a car reaches a gas station, it may stop and refuel, transferring all the gas from the station into the car. We need to return the minimum number of refueling stops the car must make in order to reach the destination. If we cannot reach the destination, then we return -1. Okay, so let's take a look at the example. Here we have target is equal to 1, start fuel 1. So basically we can go all the way to the target without visiting any station, right? So we return 0. Come here, we have target is equal to 100 and the start fuel is equal to 1, right? So we cannot reach this station, right? Look at 10x axis, right? We can only traverse 1 into the east, 1 unit to the east. Therefore we cannot reach the target and we return -1. Here we start with 10 liter of fuels, right? We will visit this gas station and then we will by the time we visit it, we will have 16 start fuel, right? We have 60 fuel. Now we can go all the way to this guy, right? And then we have 40 fuel, and then we can go from 60 to 100. Therefore we reach the target and then we use 2 gas stations. Therefore we return 2. So basically the intuition for this problem is that we can basically use a greedy approach, right? Let's say that for each station, for each like step that we take, we need to make sure that we need to somehow get to the next gas station, or we need to get to the target, right? And in order to do that, we traverse as far as we can, and we are going to check for every gas station that we have passed, right? We have the option to use it or not, right? So if we are going to use a gas station because we cannot reach the next gas station, right? For example, we go from here to 10th. Now we cannot go to this guy, right? Now we have already passed 1 gas station, so we need to take this guy, right? Okay, now we take this guy. We are at position 10, right? We will go as far as we can, and we will reach 70, right? We reach 70. Now we have all of these gas stations available. What we cannot reach 100, right? We are running out of fuel, and what gas station are we going to visit? Of course, the gas station with the largest fuel, right? In this case, it is this guys, and that's basically the intuition on how we can do this problem. We are going to use a heap and use greedy algorithm, and let's implement it with me. So for an edge case, if target is actually smaller or equal to start field, we can just simply return 0. Right? We have a queue, and then we will have didn't use, which is also a queue. I will go into later why we need this heap queue, right? Okay, so we are going to sort the station. What are we going to sort it by? We are going to sort it by basically the position, right? Okay, we can do this. Station sort key. Yeah, we can do that, right? And then what we are going to do next is that let's say y current, let's init a variable called current position, which is initially at 0, right? Y q is actually y current position is actually smaller than target, and what? And start field is actually larger than 0, right? Or we can just say y start field is actually larger than 0. We go as far as we can. Start field. And then what we are going to do next is that we're going to decrement the start field to 0. Right? We use all of our field. Okay, now so after that, then we need to pop out all of the gas station that we have passed, right? We will pop it into a heap called didn't use. Okay, so y q and yq. So no, we need to handle if current position is actually larger or equal to target. We need to break this loop, right? Else, we don't need an else here. Yq, if q 0 0 is actually smaller or equal to current position, if q hit push didn't use push to new one hip pop. Okay, so let's say that hip hop position field is equal to hip hop station, right? Okay, so the didn't use will actually be a max heap, and it will store all of the field of each stations that we have passed, and then in order for it to be a max heap, we need to add in a negative sign here, right? Field. That's it. Okay, so now we are adding all of the gas stations that we have passed into didn't use queue. Okay, so what's the next objective? The next objective is that we need to reach the next gas station, right? Because now basically we are running out of fuel, right? we are running out of fuel. We need to reach the next gas station, but if we don't have any gas station left, if land stations is actually small, larger than 0, and then basically what we are going to do, current y land didn't use, it's actually larger than 0, right? Next station position will be station 0, 0, and then y next station is actually smaller than next station position, and it's really hot. We need to reach the next gas station. Next current position smaller than next station. We will pop the gas station that we have passed but didn't use with the largest fuel, and then add it into our current position, right? Is that right? And then we will keep doing that. Okay, so after that, then if current position is actually smaller, still smaller than next station position, we return -1, and then if else break, right? If we cannot reach the next gas station, then we just break, right? Okay, so now what are we going to do next? What we are going to do next is that there's actually an HK here, is that even though we cannot reach the next gas station, there's a possibility that we can still reach the target, right? Okay, so y current position smaller than target, and land is actually larger than 0. After doing all of that, and we can still not reach the target, we just return -1 also, right? Now we just need to return the land of station, which is the number of all the stations, right? Fuck, here, need to do it here. And minus land queue minus land station minus land didn't use, right? So basically there's a possibility that we haven't surpassed all the stations, right? Hence we need to minus the land station and land of didn't use. Let's hope that it's good enough. YQ, okay, Y station. Station servers. Should be good enough. Okay, so it doesn't. On 2, on -1, 0, on 1, 0. That's actually really weird. $10, $20, $13, $16. That sounds right. Okay, so now square. This is weird, man. Fuck. Need to add it to the start field, right? And here we add it into the current position. I think that's it. Still wrong. Start field. I think that's it. Yeah, and as you can see, it's pretty efficient, right? Actually on log n time complexity. Oh no, let's analyze it thoroughly. Basically then what we are doing here is that in worst case possible, then we are going through all of the stations, right? Then we need to pop from the station, and then we need to push it into a queue called didn't use, right? And that queues in worst case possible could contain all the LAN of the stations. Hence it could be all log of LAN stations, and then this while loop, what's the maximum, how long can it go? Basically, if we have a start field of target, and then whole target, right? That's it. And then space complexity will be open LAN station, and that's it. And I hope you guys understand the solution. And it's very hard to implement, right? And I'll see you guys in next video.